I'm starting streaming.
Oh, do we want to send out a snap to the family chat?
Yeah, we do.
Oh, this is. No. All right. Did we live?
Dude, we are live. Dude, are you gonna? You should send it to the chat.
Send it. The only problem is I'm using my phone, and that'd probably exit me out.
Good point. Okay.
Let's see. I could send emails.
I just sent it.
Okay. Dude, you see this facial hair, dude? I'm trying to look like you.
Nice. Okay. Alright, so should we start with that question that
Yeah, is your brother on? We need to make sure your brother's on, right?
yeah. Um Dude, no one's even said anything in the live chat yet. What is this?
What, says there's 4 people watching. Nice.
Okay, well, we can at least start by writing out the question that we've got, right?
Yes.
Hold on.
Is there... Uh, amount of time it would take to go 50 miles. There it is.
Whoa, dude.
And then the second question is, how fast? And oh, that just covers it. There you go. Two little questions. Is there a way to make it bigger? Haha. Haha. Okay. So, Kip, you know a lot about physics and kinematic equations. Uh, I know that we could use some of those to help us solve these two questions. You want to help us out a little bit with that?
Sure. So starting out, how complicated do we want to get here?
Let's start not very complicated, so like distance equals rate times time, and then we can add a little bit more
Okay.
complexity to this.
All right. So our equation that Jaden just said is um, distance is equal to the rate times time. Or another way to say it is distance is equal to velocity, which we'll use as a v, times
Yeah.
time, okay? So just for, in this case, we've got, we've got 80 miles an hour, right? Not 800, that's way too fast, dude. You'd get pulled over in a second.
You're trying to break the sound barrier.
Almost made it. Um, and so, but this is miles, right? And that's
Right.
per hour. So if we just think about this, what this actually means for a second, is that means that you will travel 80 miles every hour, right?
Right, that makes sense.
So if you multiply it by a time, you'll get how many miles you've gone, right? So that's why this equation is pretty straightforward and makes some pretty good sense, right?
Okay, so this time is in hours, not like
Yes,
minutes, seconds. Okay.
right,
And
because we're in,
how do we know that it is hours that we're talking about?
because of our units here is miles per hour. If
Okay.
it was miles per minute, then our time
Okay.
would be in minutes. Um,
Gotcha.
so it's based on our units here. So it says how long would it take to travel 50 miles at 80 miles an hour? So our time is, or it's our distance is going to be 50 miles, right? And
Right.
then we've got this is equal to um, our speed, which is 80, and then we've got our t time here. So all we
Okay.
do is we just divide both sides by 80.
I just need to solve for the time.
Yep. And so then we've
Okay.
got 50 over 80, and this is equal to, 5 over 8, right?
Right. And that's
This is
hours.
hours. So Jaden, what would we do if we wanted to turn this into minutes? Because I don't know what 5/8 of an hour is.
Okay, so we need to figure out how many minutes are in an hour. Most people know that. You'll be surprised though. So there's 60 minutes in 1 hour, right? So if we start with this 5/8 of an hour, we have 60 minutes for every hour. That's an H. And this is minutes up here. Okay. If we just do a little bit of a math problem here, we multiply the 5 times the 60 and then divide by 8. Our hours cancel and we're in minutes now.
Dude, that's mathematical.
So that is mathematical. It's amazing. So 5 times 60, what is that? 300? And then we
Yes.
have 300 divided by 8. Um, let's do some quick maths here. 300 divided by 8, we get 37 minutes and 30 seconds.
37.
37.5 minutes. Okay.
Cool, dude. That's pretty fast. That doesn't take that much time to go 50 miles. Okay, so this
No.
is part one. So now we need part two, right? Which
Right.
is if you're traveling 30 or 50 miles in 30 minutes. Okay, so we're going 50 miles per hour times time, which is 30. Oh, wait, what am I saying over here? Dude, I wrote that out wrong. My bad. Here we go.
Oh,
So,
no problem.
so we got
Uh,
30 minutes and we need to travel 50 miles. Is that what it says? So
yeah.
30V equals 50. Now, if you remember
Yes.
though, we probably want this in miles per hour because we're in the United States and that's pretty standard in the United States. So we need to change our
Yeah.
time again from 30 minutes to uh, hours, right? So if we do the
Right.
same thing you did before, 30 minutes, and then we have um, 60 minutes in 1 hour. And so
Yeah.
cancel those out. So we get 1/2 V equals 50, right? And so
Okay.
then we divide by 1/2 on either side. I'm running out of room here, but we divide by 1/2 on either side and you get V equals 100 or 100.
Yes. No,
So,
that's not a dollar signs for
no,
all of you that are like the money greedy people out there. It's one, right?
yeah. So it's 100 miles per hour. Now, I like this. I like this question a lot because so there's some people out there that are speed demons, right?
Right.
And we just
Yep.
calculated if you're going 80 miles an hour, right? That it's going to take you um, 37.5 minutes to travel 50
Right.
miles. To only lose 7.5 minutes, you have to go 20 miles an hour faster.
That's not very much time.
No, and when you think about it, if you're trying to race somewhere and get somewhere and you're worried about, making it on time, people are always like, oh, I gotta go fast. It's like you hit 2 stoplights in those 7 minutes that you gained are now gone. Or if you get pulled
Yep.
over because you were going 100 miles an hour, you're also,
Then you're behind schedule. That's going to take a lot more than 7.5 minutes.
yeah. So this question is
Yeah.
solved.
Solved. Okay. So you mentioned how complicated we wanted to make this. What did you mean by that, Kip? So in
So
this
I'm,
situation, we use this simple equation. How can we make it a little bit more accurate?
yeah. So I'm gonna go to a new slide here and we're gonna start talking about things. So in this case, there was um, a constant velocity, right? This this driver, was not changing their speed at all.
They were on cruise control in a vacuum.
Yeah, exactly. Um,
Okay.
and so that what happens in the case, Jaden, where you say, you're slowing down or speeding up, right? Things change
Uh-huh.
a little bit there.
Yeah.
It's not so straightforward as just simply going, you know, just simply trying to calculate rate times time equals distance. We have to add something in called acceleration, okay? Which we're going to
Okay.
signify as an A. And the units, since we're talking about units, is going to be a distance, okay, divided by a time squared. In physics, we normally
Okay.
signify that by using
Hmm.
sorry, I'm just reading the chats here. I haven't been looking at the chats, but we got a sweet, and then we got you two are so handsome, dude.
I just
And
read that too.
and then we got a didn't realize my second question had such even numbers. So
Well, if you want not even numbers, type it in the chat.
yeah, give us something real hard. And then so anyways, we got a distance divided by a time squared. Normally in physics, this is going to be in meters divided by seconds squared. And what the acceleration is it's how quickly your velocity is changing, right?
Right.
So if you've got a car that's traveling this direction, right, it's going to have a velocity associated with that v. But if it's slowing down, you're going to have this minus a term, right? And so it's gonna get slower and slower. Well, if we draw these three things out on a graph together, I'm gonna draw a pretty graph here. Ooh, let's get some graph paper. Thank you.
There you go.
So in this situation that I'm talking about where you have a negative acceleration, something's slowing down, so we're gonna start with the blue color is gonna be distant, or we're gonna start with acceleration, okay? So we're gonna say we have a negative 1 meter per second squared acceleration, okay?
Okay.
So it's just gonna be this flat line, okay? Like this. And our x-axis, by the way, is time, okay?
Our
Um,
x-axis is time.
and our
Okay.
y-axis is gonna be different depending on each thing we're gonna look at here, okay? So that's,
So we'll talk about acceleration, velocity, and displacement.
yeah, exactly.
Okay.
And so if we look at this, let's say our velocity started with, what is that? That's 1, 2, 3. Okay, we got a velocity of 3 to start out with. That's going to be in meters per second. But it's slowing down, right, with an acceleration of 1 meter
Right.
per second squared. And so what that actually means is that if you look at this, that means that every second that this thing travels, it's going to slow down by 1 meter. So we'll go over, or 1 meter per second. So we go over 1 and down 1, over 1 and down 1, like this, and we get this line that looks like this. This is our velocity graph, okay?
Right.
And then, let's throw in some yellow here for our distance.
Look at these fancy colors here.
Yeah, and so our distance is going to look something, our displacement is actually going to look at like something like this. If we start at 0, it's going to start going up, right? And our displacement's going to
Right.
start going up, but it's going to start flattening out, and that's not entirely correct here. It's going to flatten out when our velocity hits 0, so right there, and then afterwards our displacement's going to start going back down, because as we've talked about a lot in this course, there's no way to really signify which way something's moving with numbers other than its sign. So when we get to a negative velocity, that actually means that the object is going to start moving backwards in time. Or not in time, sorry, will move backwards with its direction. And so you get this
You
kind of,
solved time travel, dude.
dude, yeah, I did. I'm super smart, man. Okay, so
Yeah.
if we want to take this even further, Jaden, you know calculus, so we're going to talk calculus for a second here, all right?
Hey, I like calculus, yeah.
Okay, so if you look at this, Jaden, and just looking at what you know about calculus, if you look at your acceleration and look at your velocity, do you see any correlations between the two if it was in calculus?
Well, yes, I do. So if you take derivatives and integrals, right, that's so the velocity, if you take the derivative of that, you get acceler. Wait, or is it the other way around?
So if you take the integral of acceleration, right, you get
You get velocity.
velocity, okay?
Yes,
And if you take the integral of velocity, you actually
you
get
get
the displacement.
displacement. Yes.
So if we take the integral of a, this equals v, and if we take the integral of v, this equals d. Do you like my notation there? Super accurate. Sorry, this is
Yeah.
there's a really important factor here. Very important thing that I forgot. This is with respect to time. So it's dt equals v of
Yeah.
t. And this is v
And
dot
then you could
dt.
add plus C. What does that plus C mean?
So that plus c is a constant, okay? And I actually had this question the other day, and trying to figure out what that plus c is. And what that
Okay.
plus c is so as you see, we've got this v of t equals plus c. And so if we were to say t equals 0, um, actually, well, I mean, so if we were to actually write this out, it would become, the integral of a would become at plus c, right? And this is equal to v of t, like that. That's technically the right way to write this out, okay? Right, if you actually took the integral, you'd get a of t plus c equals v of t. And so if we
Okay.
were to say t equals 0, this term right here, a of at would go to 0, right? So you'd get 0 plus c equals v of t, or v of 0, sorry. So what c actually
Right.
equals is your initial velocity. So
Okay.
what speed you started out with.
Nice.
And then if you take it again, if we take this integral again, so if we take the integral of a of t plus c, and we're going to change this because we just proved that this is vi, so we're going to say that this is vi, and this is dot dt. If we take the integral of that, we get 1/2 a t squared plus vi t. I'm going to rewrite this down here a little bit because I'm running out of room again. We
Yeah.
get 1/2 a t squared plus vi plus c. Or I guess we'll use a different constant now. We'll call this d.
Put in the T with the VI term.
Thank you. Equals,
Yeah.
we'll call it capital D for displacement. And if you look again, this constant little d, if you notice, when we plug in a 0 here, these are all going to be 0 again. And so this d term is actually going to be our initial starting point.
Ah,
So, and
that's
if
very
you,
fancy.
it is pretty fancy. And the other thing to notice is remember the original equation that we had to solve the last problem was Vt equals D, right? I guess we change this to big D, or we'll just call it D of T. Um, and if you notice, that is actually this term right there. So this is the term without acceleration associated with it, but we actually have to
Okay.
account for it for acceleration, and so this is where that term comes into play.
Okay. So in real life, we are always changing speed and direction, and that is what causes this acceleration term to actually matter in everyday life, right?
Right, because like when you, let's say you're at a stoplight, right? You're gonna have to speed up, right? And
Right.
then, and so there's an acceleration. It's something we all are very familiar with. You know, when you're driving, you feel it, you know it's there. Um,
Okay.
but you know, for the most part, that question that we solved is very simple. But when you're on a freeway and just going along, I call it, you know, it's like the human conveyor belt, right? You just hop on and just go. You could get pretty
Right.
close to um, not having any acceleration to worry about.
Yeah, that's what we did at the beginning is a really good approximation if you're on a freeway, right? If you're
Right.
just traveling pretty close to the same speed, that time that we gave you is going to be pretty accurate.
Exactly.
Okay.
Cool, cool. Where do we want to go from here?
Are there any other questions? Not yet.
Not yet.
Okay.
Here, dude,
Okay. Well,
I'm gonna push mathematical again.
it, I would say what you just explained and taught us was more mathemagical, dude.
You think, dude?
Yeah.
Dude, there's no such thing as magic.
Oh, right. I like how like some professors, if they're like, "Oh, I don't actually want to prove this," or just like do some hand waving, and then
Yeah.
they're like, "Here's the answer," and you're like, "Wait a second."
Dude, that drives me insane when people do that. They're like, yeah, and then you just do this, and then you get to this.
Uh, they're like, I messed up somewhere, but I know the answer. It should be this, and they're just like, write it down, and you're like, "Wait a second."
Yeah, dude.
Okay. So we talked about Katie in gaming, right? So kills,
Oh yeah.
death ratio, right? Why it's important to start off strong rather than finish strong in a ratio type situation. And why is that?
So, for those of you that don't know, a kill death ratio is exactly what it sounds like, but it's how many kills you got divided by how many deaths you got, right?
Okay.
And this is for, you know, there's lots of video games out there that do this, like Call of Duty and Halo.
Oh, I was just gonna make that an exclamation mark.
And it's actually it's one of the, you know, it's one of the biggest terms out there that or biggest, I don't know, indicators people use out there to prove how good they are at a video game. So
Yeah.
we'll take, for example, if we have 2 kills for every 1 death, right? Your KD is equal to 2, right?
Okay.
So that's pretty easy, right? But that's also the same as saying 500, right, divided by 250 is still equal to KD of 2.
Okay. So right now, just from those two ratios, uh, I can see that changing that first one would be a lot easier than changing that second one, right? It would each kill or death would influence it a lot more than each kill and death would the second one you wrote down.
Right. So like for
Even
example,
though they're equivalent. Huh.
yeah. So for example, right, if in a game you got 2 kills and 1 death, right?
Right.
Which is a pretty slow moving game, and I'd probably be bored out of my mind if that's how slow things were moving. But
Yes.
I'd probably be like a sniper out in the corner camping somewhere, just waiting for someone to come by.
You get your action, 2 kills,
Yeah.
1 death. That whole game, yeah.
But anyway, so if in one game, but the next game I get 3 in one, right?
Right.
Then my KD for that game would equal 3, right? Which is better.
Right.
I'm getting a little more brave. I'm getting out there. I'm killing a little more folks. I'm not quite as boring as I used to be. Um, but the thing is though, is if we want our KD total, it's actually going to be the average of the two of those together, right? Um,
Okay.
am I wrong in thinking that? I'm pretty sure that's right.
I think there's two ways. You can either add all of your kills and all of your
Right,
deaths and then do the same ratio, right? In
right.
that situation, it would be a
5 over
5
2,
over 2.
which gives you 2.5.
Um, yeah. And then if you were to just take the average of them, you would also get 5 over 2.
Yep, you're absolutely right. So the thing is that this second game, right? We did better, but our KD didn't go up that much. Um, and so the thing is that if I've been playing Halo, let's say Halo, because Halo is one of my go-to games. It's my main. So if I'm playing
Dude, kids these
Halo
days
and
don't
I
even know
played
what that is.
what?
I said kids these days don't even know what that is.
I know. It is probably the best first-person shooter multiplayer game out there. So if you haven't played, go take a look. We are totally not, what's the word, getting paid to say that. So yeah, we're
Yeah, we're not sponsored.
no, we're not. We're far from it. But let's say that I got 1,000 deaths. Okay,
Okay.
and this is after I've been playing for a long time, and I started out pretty good. I had this, 2-to-1, 3-to-1, but then I got really risky, and after a long time playing, I'm to 1,000 deaths, and I'm only to like 700 kills, right?
Ooh.
Now I'm at point 0.7. Now this is bad because anyone that plays a lot of video games knows that if you have below a 1,
Yeah,
then
you're.
then you're bad because that means you're dying more than you're killing. So
Yep. So,
so
Kip, this is
yeah,
something that I was just thinking about. If you have a perfect player, right? Let's say they did 10 kills and they died 0 times. In the KD ratio, we would say that just equals 10. But in math,
it does not.
yeah.
It equals
So,
this, dude.
yeah, what's wrong with that?
Um, well, the thing is that you can't divide something by 0, right? Another way of thinking of division is how many times will something go into a number, right? So it's like 0 times, a number, question mark, equals 10, right? Well,
Right.
we know from math that 0 times anything is always going to equal what, Jaden?
0.
So, is it possible for something times 0 to ever equal 10?
Uh, not of my knowledge, no.
Not of mine either.
No.
Um, and so you get this thing where it actually, because of that, it actually becomes something called undefined, right? So your ratio in that game would actually go to essentially infinity. So
Right.
you'd be really
So
good.
that kind of is like taking a limit as something approaches 0, right?
Right.
That's how you could get it to infinity, but
Right.
the situation a little different.
Yeah. So and for, mathematicians, they love that infinity thing. Um, but for the real world, it's uh, it doesn't exist, right? And so you're actually kind of cheated out of your KD when they do this a little bit because you actually 10 over 10, if you've got this is actually equal to 10 over 1.
Over.
So
Yeah,
so you could actually get one death and have the same as not getting any deaths, which is, they're cheating the system there.
yeah, they are.
So always get your freebie death. You can always die
Yeah,
one time and no one will know. However, that will
that
affect your.
that's the difference between like pro gamers and like your high solo players, you know?
Yeah. The only thing that's different is it affects your kill streaks in Call of Duty. So,
Yeah.
anyways, back to
Okay.
this. So we got 700 kills and 1,000 deaths, right?
Right.
And but now I want to get this to become greater than 1, right? So I would have to,
You're gonna
uh,
have to make up a lot of ground.
yeah. So if I was to not die, right, I would have to get 300 kills without a single death, um, to get up to a 1. So you know, that's some serious killer gameplay right there.
That's
But
some sweaty gamer.
super sweaty, getting like 20 nukes in Call of Duty right there. But one thing here, I'm going to a new page because we're running out of room here. But one thing
Yes.
that we could do is let's say that I have I want to figure out how long it's going to take if I change my KD to a 1. If I'm getting, let's say, you know, if my average is gonna per game is gonna be 10 to 7, right? So 10 kills for 7 deaths. That's how much better I've gotten. Okay.
Okay.
And so we want to figure out how many games it's gonna take to get my KD from 700 over 1,000, which is equal to zero point 0.7, right? We want to get this to
Right.
be equal or greater than um, yeah, 1, right?
Okay.
So, Jaden, how would we do this? I think you got this one.
So you're asking how many games of this ratio we need?
Yeah, 10 kills to 7 deaths to get us to above 1.
Ooh, so what I would do first, I might change that to a decimal just to kind of see what, like, I guess what our KD actually is. Uh, 10 over 7, that looks like about 1.4, 1.43 about. Okay. So looking at that ratio, we need 1430 over 1430. All right, to equal 1.
Okay.
Okay. Uh, we start at 700. We need to add 730 to 700 to equal 1430. Right? Are you with
Right.
me?
I'm a little confused, but we'll see how this goes.
I'm just thinking out loud, you know. Okay, so 700. What did I say? 730,
Huh?
and then that would be only 430.
Wait, where's the 730 coming from?
Because I started here, right?
Yeah.
700 plus 730 equals 1430, and then 1000 plus 430 equals 1430. Are you kind of
Okay.
with me
Okay.
now?
Yep. Yep. I'm getting there.
Okay, so that means I need 73 games because 10 times 73 equals 730. And obviously, this is rounded, so that's just an estimate.
That's a good
How'd I
estimate.
do?
Um, I don't know. I think what you did works. I'm not gonna lie, I'm really confused how you got there, but that's the good thing about math is that you can do it in a lot of different ways.
I
Um,
was just jumping around
the
a
way
lot.
I would do it is I would actually write out an equation that says we've got 700 over 1,000, right?
Right.
And I would put plus x times 10 over 7
Well, that's just a little crazy.
equals 1. That's how I would probably go about solving this.
Okay, I agree. I agree.
Uh,
Okay, let's finish your math here. So I'm gonna subtract 700 over 1000 on both sides. Okay, and then I have 10 over 7x equals 300 over 1000, or I can just call it 3/10.
okay.
Okay. Then I can divide by 10 over 7, divide by 10 over 7. You with me?
Yeah, I'm with you.
Okay. So then x equals, let's see here,
That's 27 over 10, right? No,
21
over 100. Wait, Jaden, what did
over
we do?
100.
That
What?
that's not right either. What?
Oh yeah, it'd be over 100.
There's no way that's right.
So, so we need to ask ourselves, what does x represent in this situation? Um, that's the question we have for ourselves.
Oh, this isn't okay. I know why this is wrong. Um, because all this x is going to be doing is it's only going to be multiplying to the top, right? So it's going to keep that 7 on bottom the same this whole time. I knew it was too easy to do it that way. So, right, if we had x equals 2, then it would be 20 over 7, and we don't want that. We want it to become 20 over 14. So this was actually supposed to be to the x. not
Okay.
times x.
Okay, that gets us a little bit different problem.
Which is
Um, so let's go back. Beep, 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 beep.
and that's still not going to be right. That's still not
Um,
right. Is it?
oh, hold up.
Okay, hold on. We need to go back to averages, I think. So we've got 700 and over 1,000, right? Plus, we got 10 over 7. So this is if we added one more game. I think your way of doing it makes more sense, even though I don't know what you did.
uh, let me.
Okay, so if we have, hold on, I think I'm getting somewhere. We gotta have a system of equations here. So we're gonna say x is equal to kills, y is equal to death.
Okay.
So we have 700 plus x, right?
Right.
Okay, and then we have 1,000 plus y, right? And this is equal to total death. This is equal to total um, kills, right? And then we want kills divided by deaths to equal 1, right? Now this is how we gotta do this. So we gotta
Yeah.
substitute.
Yeah. Alex, should we go to a new page, transfer this, or we can just erase all this nonsense that we did?
Well, your nonsense actually might be right. I don't.
I don't know. We'll see. So we have.
I have a question from Kelsey asking why did we write 300 instead of 700, and I'm not sure what she's talking about. So I'm gonna.
Oh, I think she's talking about right here.
Hmm. Well, it's
It.
because we have 1
Tra-
minus 700. So it's actually,
yeah.
that's the same as 1,000 minus 700 over 1,000 over 1,000. And so you get 300 over 1,000. Okay, let's
Yes.
go to the next.
Okay. So you wrote
So I
a
wrote,
system of equations.
yeah, I wrote 700 plus x equals total kills, right? And then I have, except I think we're gonna have one too many
Yeah, we'll
variables.
have. Um.
1,000 plus y equals, except we've got a
Okay.
ratio between x and y, so we've got our three equations. Um, kills. Dude, this is complicated.
Yeah,
Uh,
a
equals
bit.
1. Okay, and then so then we have x over y is equal to um, 10 over 7, like that, right?
Okay.
So let's say that so we know that our kills in this case are going to be equal to our deaths, right? If we multiply both sides by kills and deaths.
Yes. So that means we can just change these to the same thing.
Mm-hmm.
All right, we can just call both of those deaths or kills.
All right, so we've got 700 plus x, and we can set this equal to, so we've got 700, so what I'm going to do now is I'm going to set
Equals
deaths and kills equal
1,000
to each
plus
other.
y. Yeah.
Plus y. Okay, and then from there, what we have to do is we need to solve for y or x using this equation right here, right? So which one do you want to solve for, x or y?
Doesn't matter to me. Let's do x because that's alphabetically first.
Okay, so x equals 10y over 7. So we can plug that in for x. So we get 700 plus 10y over 7 equals 1000 plus y, right?
Right.
And then we subtract 700 from both sides, so we get 10y over 7 equals 300 plus y. You want to take it from here?
Yeah, then we want the variables on one side, so we subtract y, subtract y. This we have 10 sevenths minus 10 7 sevenths, so we'd have you get 3/7 y equals 300. And now we can divide by 3/7. So
Wait,
y.
let's, for those that might be a little confused, because we had that one question asking why, we wrote 300. Where did you get 3/7 from?
So if I write a variable here when I subtract the y, it is a 1. And then I just did some math in my head. A 1 is equivalent to 7 over 7. So I
Okay.
subtract 7 over 7's y.
So that doesn't equal 3 over 0?
No. When you're subtracting with fractions, you just subtract the numerators, not the denominators.
Got it.
You need the same denominator to be able to deal with adding and subtracting with fractions, though. Got it? Okay. So now we're dividing by 3 over 7. It's off the page. Divide by 3 over 7. It's off the page. So 300 divided by 3/7 equals 700. So, Kip.
So that's 700. Hey, I took a. Yeah. Okay, so we've
Sorry,
got 700 deaths, but we wanted to know the total number of games that we were going to need to play, right? Which isn't that hard. So we solved for y, right?
Right.
And so now
So
what
now just plug it
we've got
in.
x over let's see.
We can plug it in there or over there.
Yeah, but we need to figure out how many
Uh,
games, right? So that gives us our We're almost there. No, it's not as complicated as you think, I promise. Right?
No, I'm just laughing because it's just like
We got x over 700 equals 10 over 7. So that means that x would have to equal 1000. Is that right? I think so. So another way to look at it is how many games would we have to play?
yeah,
We'd have to play 100 games, right? Because we need
yep,
our kills need to go from, if we get 10 kills in one game, right? Or if we look at our deaths, if we get 700 deaths, or not 700, whoops, 7 deaths in one game,
yep.
and then we need to know how many deaths would it take to equal um, question mark
700.
death over 700. So we need 100 games. Woo!
Solved.
Yeah, dude, solved.
Bingo.
Cha-ching! And it's also very
Okay.
mathematical. So, this is why kids, when you sit there and say in your high school math class, when am I ever going to use systems of equations? Well, you can use it if you ever wanted to figure out how long you'd have to play Call of Duty or Fortnite or whatever to bring up your KD ratio.
Yes. Whew. That was that was a lot harder than it needed to be, Kip.
Yeah, I'm sure there is a much easier way to do this. But
Okay. Um, that was funny though. That was fun. We learned something. It's pretty good.
it just goes to show there isn't just one way to do things in math.
All right.
However, I still don't know that number that you came up with where you got what you got, but
There was an estimate, you know. That it was bad.
okay. Do you want to call it a night or do you want to keep going?
What time is it? It's just about 8. We
Yeah.
could call it a night.
Okay. So for all of those people out there that are just loving our channel, give us a like and subscribe. That way you'll be notified when we go live again. Okay. And
Yeah.
peace.